We assume the past was primitive. Stone tools, manual labor, trial and error. Ancient civilizations didn't have computers, lasers, or precision instruments. They worked with what they had, and what they built reflected those limitations. Except when it didn't. Because scattered across the world are structures, artifacts, and monuments that show levels of precision, engineering, and astronomical knowledge that shouldn't have been possible. Not just impressive, impossible. Modern engineers have tried to replicate them using ancient methods. They failed. Every time. Lock your doors, put on your headphones. Because after this video, you'll question everything you thought you knew about ancient technology. Egypt. The Great Pyramid of Giza. Built around 2560 BCE, or so we're told. The structure consists of approximately 2.5 million stone blocks, each weighing between 2 and 70 tons. The base covers 13 acres. The four sides align almost perfectly with true north, south, east, and west. The accuracy, within 1/15 of a degree. That's 0.067 degrees of deviation. Modern architects with laser theodolites and GPS struggle to achieve that level of precision. Yet somehow, 4,500 years ago, workers using copper tools and rope allegedly accomplished it. Dr. Christopher Dunn, a precision engineer with decades of experience in aerospace manufacturing, studied the interior chambers of the Great Pyramid. He focused on the granite blocks in the King's Chamber. These blocks show evidence of machining, not hand carving, machining. Dunn measured drill holes in the granite, perfectly circular, with spiral grooves indicating a feed rate, the speed at which the drill advanced into the stone, of 0.1 inches per revolution. That's faster than modern drills cutting through granite with diamond-tipped carbide bits. Dunn conducted experiments. He tried to replicate the drill holes using copper tools, the only metal available to the ancient Egyptians according to conventional archaeology. Copper is soft. Granite is hard, ranked 7 on the Mohs scale. Copper ranks 3. To drill into granite with copper, you need an abrasive, like sand. Dunn tried. He used sand, water, and copper. He applied pressure. He rotated the tool. After hours of work, he barely scratched the surface. Certainly nothing close to the clean, precise, deep holes found in the King's Chamber. Yet there they are, drilled into some of the hardest stone on Earth, with precision that modern engineers can't explain using ancient tools. Dunn wrote a book detailing his findings. He presented his evidence to Egyptologists. Most dismissed him. They said he was misinterpreting the evidence, that the drill marks were created through repetitive manual labor, not machines. But Dunn is a machinist. He's spent his career analyzing precision manufacturing. He knows what machine marks look like, and what he saw in the Great Pyramid matched industrial drilling, not hand tools. He requested permission to conduct further analysis, using modern measurement equipment. Permission was denied. The Egyptian authorities cited preservation concerns. The evidence remains inside the pyramid, undisturbed, unexplained. Move south. Puma Punku, Bolivia, an ancient site in the Andes, part of the Tiwanaku culture, dated to around 600 CC. The ruins consist of massive stone blocks, some weighing over 100 tons, cut from andesite and granite quarried from locations up to 10 kilometers away. These blocks show levels of precision that defy explanation. Surfaces flat to within a few thousandths of an inch. Corners at perfect 90-degree angles. Interlocking joints so tight you can't insert a sheet of paper between them. Dr. Jean-Pierre Protzen, an architectural historian from the University of California, Berkeley, examined the stones. He measured tolerances, surface finishes, and joint alignments. The precision, he concluded, was extraordinary. But what made it impossible was the lack of tool marks. When you cut stone by hand, you leave marks. Striations, grooves, evidence of impact. The stones at Puma Punku show none of that. The surfaces are smooth, uniform, as if cut by a machine. Dr. Protzen tried to replicate the cuts using bronze tools, the hardest metal available to the Tiwanaku people. He managed to shape stone, but nothing close to the precision found at Pumapunku, and certainly not at the scale required to produce blocks weighing over 100 tons. Here's the thing that bothers engineers. Precision at that level requires measurement. You can't cut a surface flat to a few thousandths of an inch without instruments to verify flatness. You can't align edges to perfect 90-degree angles without a way to measure angles. Yet the Tiwanaku civilization, according to conventional history, didn't have precision measurement tools. They didn't have calipers, levels, or squares made to tolerances tight enough to produce these results. So how did they do it? Dr. Pratzen proposed. They used stone tools and patience. Lots of grinding, checking, grinding again. But even with patience, you need a reference standard. You need something to compare against. Something that defines what flat or square means. Without that, you're just guessing. And these stones aren't guesses. They're precise, repeatable, standardized, as if whoever built them had access to measurement technology we don't associate with ancient Bolivia. Travel east, Baalbek, Lebanon. The ancient Roman temple complex built on top of even older ruins. Beneath the Roman structures lies a foundation made of stone blocks called the Trilithon. 3 massive blocks, each weighing approximately 800 tons. That's 1,600,000 pounds each. The blocks are cut from limestone quarried about 800 meters away, transported to the site, lifted into place, and fitted together so precisely that a razor blade won't fit between them. Modern engineers struggle to move 800-ton blocks. It requires specialized equipment. Cranes rated for that weight are rare and expensive. Transport vehicles capable of carrying that load are custom built. Yet somehow, 2,000 years ago, workers moved 3 of these blocks from a quarry, up a slope, and positioned them in a foundation wall with millimeter-level precision. No one knows how. Dr. Erwin M. Ruprechtberger, an archaeologist who studied the site, estimated that moving one of these blocks would require the coordinated effort of over 40,000 workers using ropes, levers, and rollers. But coordinating 40,000 people to move a single block without modern communication, without motors, without cranes, is a logistical nightmare. One mistake, one rope breaking, one roller slipping, and the block crashes. At 800 tons, a falling block would kill hundreds of workers and destroy itself. The margin for error is zero. Yet the Trilithon blocks were moved successfully, not just once, but 3 times. And they were placed with such precision that modern surveyors can barely detect the joints. Dr. Ruprechtberger admitted he had no explanation. The engineering required to accomplish this feat, he said in a lecture, exceeds what we would attempt today without computer modeling, hydraulic lifts, and precision alignment systems. Yet there it is, built millennia ago, standing as proof that someone, somewhere, had knowledge and capabilities we don't credit them with. But precision in stone isn't the only anomaly. Astronomical alignments show knowledge that shouldn't exist. Angkor Wat, Cambodia, built in the early 12th century as a Hindu temple dedicated to Vishnu. The complex covers over 400 acres. Its layout mirrors the constellation Draco, not as it appears today, but as it appeared in 10,500 BCE, 12,000 years ago, long before the Khmer civilization existed, long before the temple was built. Dr. John Grigsby, an archaeoastronomer, analyzed the alignment. The correlation is exact. The positions of the temple towers match the stars in Draco, accounting for precession, the slow wobble of Earth's axis that causes the positions of stars to shift over millennia. Here's the problem. Precession takes roughly 26,000 years to complete one full cycle. To know where a constellation was 12,000 years ago, you need detailed astronomical observations spanning centuries, precise mathematical models, and an understanding of Earth's axial tilt and rotation. The Khmer civilization didn't have that. They had sophisticated astronomy, yes, but nothing suggesting they understood precession well enough to design a temple layout matching a constellation from 10,500 BCE. Dr. Grigsby proposed that the temple's design incorporated much older knowledge, possibly passed down through oral traditions or inherited from an earlier civilization. But if that's true, who was that civilization? Who had the astronomical knowledge and mathematical precision 12,000 years ago to map the stars and encode that information into architecture? No mainstream historical record acknowledges such a civilization. Yet the alignment exists, measurable, undeniable. The same pattern appears at Giza. The three pyramids align with the three stars of Orion's belt, not as they appear today, but as they appeared around 10,500 BCE. Dr. Robert Bauval, an engineer and author, documented this in his Orion correlation theory. The alignment is precise. The pyramid's relative sizes, positions, and orientations mirror the stars in Orion's belt from 12,000 years ago. Again the question, how did the ancient Egyptians know where Orion's belt was positioned 10 millennia before their civilization existed? And why would they encode that specific date into their most important monuments? Mainstream Egyptologists dismiss the theory. They argue the alignment is coincidental, that the pyramids were built as tombs for pharaohs and nothing more. But coincidence requires ignoring the mathematical precision of the alignment. The pyramids don't just roughly match Orion's belt. They match it exactly, down to the offset of the third pyramid, which mirrors the slight misalignment of the third star. That's not coincidence. That's deliberate design. Dr. Bauval requested permission to conduct ground-penetrating radar surveys of the Giza Plateau to search for older structures beneath the pyramids. Permission was denied. The Egyptian authorities stated that the pyramids have been thoroughly studied, and no further investigation is necessary. The alignment remains, encoded in stone, unexplained by official archaeology. The precision extends beyond astronomy in the Antikythera mechanism, discovered in a shipwreck off the coast of Greece, dated to around 100 BCE. It's a mechanical computer, a device with over 30 bronze gears arranged in a complex system that calculates the positions of the sun, moon, and planets. It predicts eclipses. It tracks the Olympic Games cycle. The engineering sophistication is staggering. Historians believe devices like this didn't exist until the 14th century, when European clockmakers began producing mechanical clocks. Yet here it is, 2,000 years old, recovered from the sea. Dr. Derek J. DeSola Price, a physicist and historian, spent years analyzing the mechanism. He reconstructed its function, mapping how the gears interacted. The precision of the gears, the complexity of the design, suggested a level of mechanical knowledge far beyond what ancient Greece was credited with. Dr. Price concluded that the Antikythera mechanism represented a lost tradition of precision engineering, a technology developed and then forgotten, leaving no descendants until centuries later. But if the Greeks built this, what else did they build that we haven't found? And why did the technology disappear? The mechanism raises another question. Bronze gears require precision machining. The teeth on the gears must be uniform, evenly spaced, and accurately shaped, or the mechanism jams. Producing gears like this by hand is possible, but extraordinarily difficult and time-consuming. Yet the Antikythera mechanism contains over 30 gears, all machined to precise tolerances. Who made them? What tools did they use? And why is this the only example we've found? Dr. Michael Wright, a curator at the Science Museum in London, built a working replica of the mechanism using ancient tools. It took him years. The precision required was immense. Even with modern metallurgy knowledge, replicating the gears was challenging. Dr. Wright concluded that whoever built the original mechanism had access to a sophisticated workshop, skilled craftsmen, and a deep understanding of astronomy and mechanics. Yet no other artifacts from ancient Greece show this level of technological advancement. The Antikythera mechanism stands alone, an anomaly, a glimpse of something lost. Göbekli Tepe, Turkey. Megalithic stone pillars carved with intricate reliefs, built around 9600 BCE, 11,000 years ago, before agriculture, before cities, before civilization, as we define it. Yet the site shows organized labor, advanced carving techniques, and astronomical alignments. The people who built it weren't supposed to have those capabilities. Dr. Klaus Schmidt, the German archaeologist who excavated Göbekli Tepe, called it the most important archaeological discovery of the 21st century. The site consists of multiple circular enclosures, each defined by massive T-shaped pillars arranged in precise geometric patterns. The pillars, carved from limestone, stand up to 5 meters tall and weigh up to 10 tons each. They're decorated with detailed reliefs of animals: foxes, lions, scorpions, snakes, birds. The craftsmanship is extraordinary. The proportions are accurate. The lines are clean. This isn't primitive scratching on rock. This is skilled sculpture. But here's the impossibility. According to conventional archaeology, 11,000 years ago, humans were hunter-gatherers. They lived in small nomadic bands. They didn't have permanent settlements, organized religion, or social hierarchies complex enough to coordinate large-scale construction projects. Yet, Göbekli Tepe required hundreds of workers to quarry, transport, carve, and erect these pillars. It required planning, leadership, a shared vision, and it required knowledge of astronomy, because the site's layout aligns with celestial patterns. Dr. Schmidt estimated that building Göbekli Tepe would have required sustained effort over multiple generations. That implies a stable society with surplus food production to support non-agricultural workers. But agriculture hadn't been invented yet. The site predates the Neolithic Revolution, the period when humans transitioned from hunting and gathering to farming and settled life. Göbekli Tepe shouldn't exist. Yet it does. And it's not alone. Nearby sites like Karahan Tepe show similar construction, suggesting a broader culture of megalithic builders operating in the region thousands of years before civilization was supposed to begin. Dr. Schmidt died in 2014, before excavations were complete. Surveys suggest that only about 5% of the site has been uncovered. The rest remains buried, deliberately filled in by the original builders for reasons unknown. The Turkish government controls access to the site. Research permits are difficult to obtain, and the questions Dr. Schmidt raised remain unanswered. Who built Göbekli Tepe? How did pre-agricultural societies organize such an endeavor? And what knowledge did they possess that we don't credit them with? Move to South America, Sacsayhuaman, Peru, a fortress complex overlooking Cusco, built by the Inca, or so we're told. The walls consist of massive stones, some weighing over 200 tons, fitted together in complex polygonal patterns. The joints are so tight that you can't insert a knife blade between them. No mortar was used. The stones hold together through friction and precision fitting alone. Engineers who study Sacsayhuaman struggle to explain it. The blocks are irregular polygons, not rectangular. Each stone has a unique shape, with multiple contact surfaces that must align perfectly with the surrounding stones. Cutting a single stone to fit into such a pattern is complex enough. Doing it with blocks weighing hundreds of tons, ensuring that all contact surfaces align with millimeter-level precision, is exponentially harder. Even with modern computer-aided design, creating such a structure would be challenging. Dr. Jean-Pierre Protzen attempted to replicate the technique. He used Inca tools, stone hammers, copper chisels, sand as an abrasive. He managed to shape stones and create reasonably tight joints, but nothing approaching the precision at Sacsayhuaman. His joints had gaps. His surfaces weren't perfectly flush, and his blocks weighed only a few hundred kilograms, not hundreds of tons. Scaling up his method to the massive stones at Sacsayhuaman would require capabilities he couldn't demonstrate. The conventional explanation is that Inca workers use repetitive grinding, checking the fit repeatedly until the surfaces aligned. But repetitive grinding on a 200-ton block is impractical. You can't easily move such a stone to test fit it then move it away to grind more, then test again. The logistics are impossible without cranes and transport vehicles. Yet the Inca didn't have wheels. They didn't have draft animals large enough to move such weights. They had manpower, ropes, and inclined planes. And somehow, with those simple tools, they created polygonal stone walls with precision that modern masons can't match. There's another mystery. Sacsayhuaman has withstood numerous earthquakes. Cusco, a city of Spanish colonial buildings, has been repeatedly damaged by seismic activity. Modern concrete structures crack and collapse, but the Inca walls remain intact, their stones still locked together, unmoved by forces that destroy everything around them. The polygonal design distributes stress in ways that engineers are only beginning to understand. The Inca, supposedly a Bronze Age civilization without written mathematics, designed earthquake-resistant structures that outperform modern engineering. Dr. Protson admitted in his research papers that he couldn't fully explain Sacsayhuaman. The precision, he wrote, exceeds what should be possible with the tools available. The scale exceeds what should be possible with the labor force available. And the durability exceeds what should be possible without steel reinforcement and modern materials. Yet, there it stands, built centuries ago, defying explanation. Cross the Atlantic. Stonehenge, England. The iconic stone circle, built in multiple phases between 3000 and 2000 BC. The structure consists of two types of stone. Sarsen stones, large blocks of sandstone weighing up to 30 tons, and bluestones, smaller volcanic rocks weighing several tons each. The Sarsen stones were quarried about 25 kilometers away. Difficult, but feasible to transport using Neolithic techniques. The bluestones, however, came from the Presley Hills in Wales, over 250 kilometers away. Transporting the bluestones required crossing land and water. Researchers have proposed various methods: rafts, rollers, sleds, human chains dragging stones across the landscape. Experimental archaeology has attempted to replicate the journey. In 2000, a team tried to move a bluestone replica using a wooden sled and volunteers. The project failed. The sled broke. The stone proved too heavy to control on slopes. The effort required was unsustainable over hundreds of kilometers. Yet Neolithic peoples, around 4,000 years ago, moved at least 80 bluestones from Wales to Salisbury Plain. They transported them across hills, rivers, and marshes. They erected them in precise positions, aligned with solar and lunar cycles. The effort required coordination, planning, and resources far beyond what we associate with Stone Age societies. And we don't know why they did it. Why transport stones hundreds of kilometers when suitable stones were available locally? What was so special about the Presley Hills bluestones? Recent research suggests the bluestones may have been part of an earlier stone circle in Wales, dismantled and moved to Stonehenge. If true, it implies that Neolithic peoples valued certain stones so highly that they undertook a monumental journey to relocate them. But that raises more questions. What made those stones significant? Did they have properties we don't recognize? Acoustic properties? Magnetic properties? Something the builders knew that we've lost? Dr. Timothy Darville, an archaeologist from Bournemouth University, proposed that the bluestones were believed to have healing properties. Local folklore in Wales associates the Presley Hills with healing springs. Perhaps the stones carried cultural or spiritual significance that justified the efforts. But belief doesn't explain the logistics. How did they physically move 80 stones, each weighing several tons, across 250 kilometers of pre-modern Britain? The engineering challenge remains unsolved. And then there's the precision. Stonehenge isn't just a random arrangement of stones. The positions of the Sarsens and bluestones align with solar events. The summer solstice sunrise, the winter solstice sunset. The station stones, 4 markers placed around the perimeter, form a rectangle whose sides align with the most northerly and southerly moonrises. Achieving these alignments required astronomical observation over many years, mathematical calculations to predict celestial positions. and surveying techniques to position stones with accuracy measured in fractions of a degree. Neolithic peoples supposedly didn't have writing, mathematics, or standardized measurement systems, yet they built Stonehenge. They encoded astronomical knowledge into its layout. They transported stones across vast distances. They organized labor forces numbering in the hundreds or thousands. They sustained the project over multiple generations, maintaining the vision and knowledge required to complete it. How? Return to the Near East, the Temple of Jupiter at Baalbek, Lebanon. We've already discussed the trilithon, the 3 800-ton blocks in the foundation. But there's more. Beneath the Roman temple lies an older structure, sometimes called the Phoenician temple. The stones in this older layer are even larger. The stone of the pregnant woman still in the quarry nearby weighs approximately 1,000 tons. Another block, recently discovered, weighs an estimated 1,650 tons. These are among the largest work stones in human history. The Roman engineers who built the Temple of Jupiter used the older foundation but didn't create it. They built on top of pre-existing megalithic structures, incorporating them into their design. Who built the original foundation, when, and how? The Romans had cranes, pulleys, and extensive engineering knowledge. They built aqueducts, bridges, and massive buildings across their empire. Yet even they, at the height of their power, couldn't move stones weighing over 1,000 tons. Their largest known crane capacity was around 100 tons. The megalithic foundation at Baalbek predates the Romans and exceeds their capabilities. Local legends attribute the construction to giants or to Cain, the biblical figure cursed by God. These are mythological explanations, not historical ones, but they reflect a recognition that the stones are impossible. The people who told these stories understood that moving such weights required capabilities beyond normal human strength. They attributed it to supernatural forces because they couldn't conceive of a natural explanation. And modern engineers, with all their technology, still can't provide one. 8 examples. 8 impossibilities. Precision drilling in granite. Machine flat surfaces on 100-ton blocks. 800-ton stones moved and placed with millimeter accuracy. Astronomical alignments encoding dates from 12,000 years ago. Mechanical computers from ancient Greece. Megalithic structures from before civilization. Each one defies explanation using the tools and knowledge we attribute to ancient cultures. Modern engineers, with all their technology, struggle to replicate these achievements. Yet ancient peoples, supposedly primitive, accomplished them. Here's what bothers researchers. These aren't isolated cases. They're global. Egypt, Bolivia, Lebanon, Cambodia, Greece, Turkey, Peru, England, different continents, different cultures, different time periods. Yet the same impossible precision appears again and again. The same astronomical knowledge, the same engineering sophistication, as if there was a shared tradition, a common source of knowledge that spread across the ancient world and then vanished, leaving only these monuments as evidence. Mainstream archaeology doesn't acknowledge this. They maintain that each culture developed independently, that any similarities are coincidental. A coincidence doesn't explain how multiple civilizations, separated by oceans and millennia, all encoded the same astronomical date, 10,500 BCE, into their monuments. Coincidence doesn't explain how ancient stone workers in Bolivia and Lebanon both achieved precision tolerances that modern machinists struggle to match. Coincidence doesn't explain the Antikythera mechanism. If you made it this far, thank you. Leave a like if these engineering mysteries made you question the official history. Tell us which discovery you think is the most impossible and what you believe really happened. Subscribe to join us as we keep investigating what ancient civilizations were truly capable of. But remember, some questions don't have comfortable answers, and some evidence forces us to rethink everything we thought we knew.